All right, it looks like we're a minute or two here after 11:30, so good morning, everyone. Thank you for joining us on Rumsey's ongoing Locked In series being hosted by our Rumsey specialists. My name is Sean Huber. I'm one of the Automation Systems Group's managers here at Rumsey. Today we're continuing to focus on the power side of the business with a presentation specific around what can smart control sensors and safety products do for your plant. So with that, we're doing something a little bit different for this presentation. We're actually going to have three of Rumsey's IC safety and sensor specialists present during this time. To introduce them, it'll be Donna Wyatt, Will Howley, and Joe LOMONACO. All three of them cover Rumsey sales territory in all aspects of these products, both technical and commercial. And between the three of them, they have a total of over 35 years of experience. I will let them introduce themselves in better detail for kind of the general area that they cover, but I do want to stress that they all work as a team, and if one of them's ever out on a call helping somebody, one of the other ones will be there to back them right up. So with that, if all things Skype work well here, I will turn it over to you, Donna, and let you go ahead and progress the slides.
Good morning, everyone. My name is Donna Wyatt. My presentation today will be on smart sensors. I'm an industrial control safety and sensor specialist. I've been with Rumsey Electric for 26 years. And for 20 of those years, I have been a product specialist. And the areas that I cover are Delaware and Chester counties in Pennsylvania, the state of Delaware, and Cecil County in Maryland. And what's kept me going all these years is I really enjoy working with customers and assisting you on finding solutions for your machine requirements. And every day I learn something new, which that's the great thing about my job. Today I'll be talking to you about smart sensors. And basically, smart sensors are a way to future-proof your machine. And when you use an Allen Bradley IO-Link sensor, you don't have to go right into IO-Link today. Future-proofing means if you use the sensors, which already are IO-Link capable, at some other time and point, you can put IO-Link into your conveyor and get more analysis and increase your productivity. So the smart sensors are off-the-shelf standard sensors. They don't have any special wiring requirements. It's standard wiring. The quick disconnects are M12. You only have to terminate one wire. So it simplifies design and commissioning time. And it saves you time and money, which is a great business decision. So the use of IO-Link allows sensors to communicate more data quicker to the Rockwell Logix controller. So that ensures timely sensor status to the plant floor for faster resolution and increases production. And Smart Sensors offers advanced functions which allows faster setup, maintenance, troubleshooting, and more. And as you'll learn today, the Smart Sensors, Smart Safety, and Smart Motor Control all give you real-time data and analytics so you can optimize your workflow and your plan. I'll be going over three scenarios today, and these are things that happen every single day of the year in your plant. Scenario number one is a damaged sensor that has to be replaced. So, it gets smashed by a forklift or whatever. The operator will be able to detect sensor health, which is sent immediately to the HMI, so the operator can quickly identify a damaged sensor. Application-specific naming will give you the sensor part number, the manufacturer, and it all comes up on the HMI, so it saves time. So the operator doesn't have to run out to the conveyor, find out what the part number is, run back to stores, and this will save a lot of time because they'll already know, okay, what part number do I need? And automatic device configuration programs the sensor automatically, which reduces errors. So you pop in the new quick disconnect cable, attach it to the sensor, and off you go. You don't have to mess with the teach button. You don't have to check does it detect the right color, correctly. It's all done for you through the controller. And also add-on profiles simplifies setup and by organizing the sensor information and configurable parameters, which again reduces errors. So you save time, you reduce errors, you got minimal downtime, and you save money. Scenario number 2 is timely predictive maintenance because the sensor lens is dirty. So you're able to detect that the sensor signal strength is deteriorating. So once again, the sensor health is communicated to the machine operator via the HMI. The device profile, such as set point and signal strength, can be viewed and quickly tells the operator what type of maintenance is needed. So he gets out his soft cloth and he goes over to the sensor. And once again, the HMI will also, through application-specific naming, tell you what sensor is having the issue. Or the operator, with a touch of a button, can activate the LEDs on the sensor to blink very quickly so it identifies the sensor visually. Predictive maintenance will address the issues before the line stops, which increases production. And also it reduces errors, saves time, keeps the line running, which makes your CEO very happy. Scenario number 3 is quick sensor reprogramming due to a change in the product that's being run on the line. This YouTube video that I reference is a great video that will explain this whole thing in 50 seconds or less. But unfortunately with Skype, we can't show it. So basically, if you look at the picture on the right, we've got 2 products that are coming that are programmed for this one specific line. First one's a yellow bottle with the cap and the label and the height. That's what the 4 sensors are looking for with this yellow bottle. The next thing that's going to be run is the blue bottle. So the 4 sensors are looking for the same thing: the color, the height, the cap, and the label itself. So when you use multiple sensor profiles, you can program them all in your logic controller, which is a really smart thing to do because then it's programmed, it's done, you don't have to worry about it anymore. So when you're running from the yellow product to the blue product, the sensor needs to adjust the color and the label and the height that's going to be detected. So the operator simply pushes a button and the change is made on the run. And the operator is extremely happy because he doesn't have to futz with all that programming. And also some I/O link sensors can also run counts and timers for you too. So that can be just a bit that has to be programmed. So when you use the sensors for quick reprogramming on your line, it minimizes downtime, increases throughput, and reduces scrap, which is, once again, everybody's happy. I'm just going to go over a couple of the new sensors that you might not have seen. And these are all I/O link enabled sensors. The first one is the 42AF, which is a high-powered right sight. Now, you probably have seen the 42EF sensors everywhere in the world. I mean, they are literally everywhere, and it's a great sensor. The 42AF is pretty much the same thing, except it's a high-powered sensor. It's mid-sized, and it's used in a wide range of applications. It's I/O link enabled. It has a robust housing. This one allows you a 30 millimeter nose mounting as opposed to the right sight with the 18 millimeter nose mounting. And then also has an 18 millimeter base mount. It's the LEDs on the top for diagnostics are highly visible. It's an IP67, IP69K enclosure. If you're using it in transmitted beam mode, you can get up to 80 meters. polarized retroreflective, you can get 10 meters. It's also available with the other sensing modes, but I'm going, highlighting background suppression and background reflection, which is which are great modes to detect when you don't want to use a reflector. The outputs are dual auto NPN PNP, which, if you haven't heard that before, let's say you're using sourcing. Everything's wired for sourcing on your line. If you just use the 42AF, it has auto detect, so it knows right away that it's wired for NPN. So literally you only have to buy one part number and it gives you any, PNP or NPN in the one sensor. No programming needed. And if you use an AC voltages, it's also available with a single pole, double throw, electromechanical relay. And then on the slide, I also put the link for you to make it easy to find when you receive the presentation. The next sensor I just wanted to tell you about is the 45 DMS, which is a distant measurement sensor. IO-Link enabled again. It's a class 1 eye-safe laser. It's ideal for precision distance measurements like web control and roll diameter. The sensing ranges are up to 5 meters on white paper or 3 meters on black paper. And it has good accuracy, 1 millimeter resolution, IP69K rating. And it's good for distance measurements, as I said, and background suppression and background reflection. And the last sensor I wanted to go over is the 836P pressure sensor, and can also put the same requirements in for the 837T temperature sensor. They're both IO-Link enabled. They both have display and non-display versions. They're 316L stainless with an IP67 enclosure. They both have PNP and analog outputs. The pressure can go up to 8,000 psi, and the non-display pressure can go up to 10,000 psi, and sanitary options are also available. The temperature 837T can also has 25 to 350 millimeter probes, and its temperature range is -20 to 80 degrees C. And they both have PNP and 4 to 20 analog outputs. Lastly, I just put a slide here on a couple of blogs if you have time you might want to look at. The one for Rumsey there, the first one, the integrated smart sensors for a smarter machine. I had written that recently, and it has some good information. Rockwell has a couple of good smart sensor blogs, and I listed one here. And then I just included the general sensor website and IO-Link website. And just to wrap up, IO-Link smart sensors can reduce inventory and operating costs, increase productivity and uptime, simplifies design, installation, setup, and maintenance, and enhances flexibility and scalability. So if anybody has any questions, I'd be happy to take them at this time. If no one has any questions, I will introduce Will Halley. He's going to be doing smart safety.
Thanks, Donna. So as Donna said, my name's Will Howley. I am an industrial controls sensor and safety specialist here at Rumsey Electric, and today I'll be going over smart safety, which in Rockwell's world from a component perspective is called GuardLink. So I've been with Rumsey for 5 years now, and I primarily cover New Jersey, Philadelphia, Conshohocken, and the southern Bucks and Montgomery counties. But as Tony and Sean said, we kind of work as a team, so we back each other up. If one of us is out, you may get an email from me, even if you're in Delaware or Maryland, and vice versa for Donna or Joe. So before we get started, just a few high-level things that I want to go over, kind of concepts for a GuardLink system. So essentially, as I stated before, it's a smart system, and what that means is, most of you are probably familiar with, it's able to get data out of devices and pull that data into a larger safety system, into a safety PLC. And we'll go into the specifics of that in a bit. Additionally, it's simple, so you really have very minimal configuration, and it uses standard input devices and basic 5-wire M12 cables and connectors. So you really don't have anything that is too out of the ordinary in terms of a hardware perspective. And finally, it's safe. So you're able to daisy chain up to 32 devices with no loss of safety rating. So you can get those maximum safety ratings of PLE, CEL3, or CAT4, and you can do that relatively easy with this system. So now we're going to get into the specifics of some of the hardware. And first and foremost, that starts with the taps. The taps, from a kind of a marketing perspective, are the face of a GuardLink system. If you were able to attend Automation Fair in 2018, you probably saw these. There were quite a few demos that had these on them. They are essentially a mini safety relay that takes a status from an input device, shows its status locally on a machine with a green LED, and then is connected to the next tap with just a standard M12 cable. So these are rated IP67, so they can be used in washdown areas. And like I said, you're essentially going to have multiple devices connected in series. So you're going to have an M12 cable coming in one side and an M12 cable going out the other side. The exception being the last tap would have a shorting plug on the end, and that would allow the system to know that that was the last tap. The bottom LED is showing continuity of the chain, so if a device that is not connected to a specific tap trips, that bottom LED will flash red, letting you know that there has been a break in the chain, but also that it is not that specific device. So that can help you diagnose which tap tripped, which device tripped, as opposed to having to walk around your machine or your plant and, you know, kind of try and eyeball it, save you some time in diagnosing the issue. The next piece of hardware that we wanted to go over is the master relay. This is kind of the brains of the GuardLink system. So essentially, this is similar in a form factor to a standard GSR relay, which some of you may be familiar with. And it is taking the input from the GuardLink taps and the input devices, and it is checking their status. So as you can see, it has a configurable dip switch on the front and a rotary dial to help program it locally. And it has a number of LEDs on the front to show status. And what the DG relay does is it sends a safety pulse through the GuardLink chain, and it determines which one is the last in the series, and then it essentially counts backwards from that through to the devices, of which you can have up to 32 connected in series, and that safety pulse allows the relay to know which device tripped. At the top there you can see the terminals, and it also is able to do remote resetting. Now, if you wanted to use GuardLink simply as a local device, so just providing that visual indication and help with troubleshooting locally, you could. However, you're only getting kind of a portion of its capabilities. Where its true value is shown is when you bring in this Ethernet module, and this is paired with GSR relays like the DG relay, the dual GuardLink, and it is connected with an optical bus. So on the back end of the Ethernet module, there are little kind of taps that hook into the relay, and it's able to communicate that way. Essentially, it has an embedded switch at the top, so it supports device level ring topologies, and the 3 rotary dials there are to set the IP address of the system. And in a second here, I'm going to show you kind of how this would look as a complete system, and then how you could tie this into kind of a broader safety system if you're using a safety PLC. So right here we have all the devices that we just went over. We have the taps, we have the cables, we have the DG relay, we have the Ethernet module, as well as some safety input devices. Here we have some non-contact switches, a guard locking switch, and an e-stop. But the system is not limited to those devices. You could also use light curtains or a traditional electromechanical guard locking switch. And then, as you can see on the left here, we also have a PLC and an HMI. So here we can see what the LED indicators look like on the individual devices. So if you weren't using a system like GuardLink, that would be the only local indication that you have. Now, you may have machines in your facility or that you build where these may be tucked away, where they're not really all that visible. So that may not be sufficient for an operator to diagnose what's going on, or maybe which door tripped, or what really tripped your safety system. And this is where those taps that we went over come into play. So you're basically going to run these around your machine, and they're going to be nice bright LEDs that visually indicate each device. So you're not running around with a flashlight looking to see, if there's a green light tucked away behind behind a door. So here we have just a non-contact switch, just what we would call a sensor guard. And when the door is open, you can see that the top circular LED turns red, and all of the other ones will start flashing, and the chain at the bottom is broken. When you close it, it resets, and you can start your system back up. Similarly, if you were to hit your e-stop, you would have the same output. The chain would break, the e-stop would light up, and all of the other taps would start flashing, and the chain would be broken. You reset it, and you're good to go. Now, as I said before, bringing that Ethernet module into the GuardLink system is really where you can unlock its value, and the primary way that we can help to not only save you money but time is through reducing your engineering time and being able to replace devices when they go down. So DONNA mentioned add-on profiles and what we call automatic device configuration. So an add-on profile essentially is going to be a download from Rockwell's website that will give you the ability to integrate your Ethernet module into Studio 5000 much easier and faster with pre-populated and descriptive tags, as opposed to doing that manually with potentially a competitor's device. So really significant time savings there. And here we kind of have just a roundup of what the savings are. So overall, it's really not as complicated as safety can seem to be at times. I know it's kind of a taboo subject that people don't want to get involved in, but with a technology like GuardLink, you can really kind of demystify that sort of thing, and really, make the implementation and management and maintenance of these systems a lot easier. From a cabling perspective, it really provides you the ability to save a lot of money. Not only are you saving money from the actual devices themselves being cabled, but you don't have to home run a wire back to a safety relay or an input card. So significant savings there if you want to reduce your I/O count, or in the past, people typically used distribution blocks to wire to, and then you're running maybe an 18 or a 23 wire cable back to an I/O card. With GuardLink, you don't have to do that. You really just have one input going into that DG relay connecting over Ethernet, and really saving you a significant amount of money on cabling. And like I said, significantly reduced I/O, daisy chaining these components in series, and still being able to attain the highest safety ratings. So PLE is what we're talking about there. And that's kind of just the overall message that we want to reinforce here, is that from a total cost of ownership standpoint, you can really save yourself a lot of money, especially from kind of a user standpoint, but also from an OEM perspective, from saving engineering time, and also potentially differentiating your machine from competitors. Just a quick reminder here, we have pre-engineered safety functions which Rockwell puts together. So if you're a little bit confused about how you would implement this or how you would wire it, you may have seen things like this image on the screen right here. And what Rockwell does is they will put together a complete safety function with devices, wiring diagrams, and explanation of what those devices are and how they would be implemented. And then for a lot of them, they'll actually also have Systema files, which you can use to validate your safety function. If there's not one that specifically matches what you want to do, a lot of times we can kind of take two and kind of mesh them together and put together something that comes really close to what you might be using on your machine. This one's from the user manual. You guys will get a copy of these slides, so it's on page 61 of the user manual. But we also have a couple other ones that show guard link and go into a little bit more depth than we went into here. Finally, here are a few links that will be on those slides that you get as well. The landing page on ab.com, a recent blog from rumsey.com, which we wrote that kind of echoes what we went over here today, a brief YouTube overview, as well as an interactive smart safety brochure. Similar to Donna's video that she has, this has a lot of animations that will really help you visualize what we were talking about today. And you can kind of see what this would look like on a line and, really kind of hammer home the points and hopefully, give you the ability to see the value in a system like this. And with that, I will hang on for any questions. But next up is Joe LOMONACO. He is my coworker, and I will hand it over to him for smart motor control.
All right. So Joe LOMONACO here, and we'll be looking at smart motor control to bring up the rear. So I've been in the industry for 11 years. I've been a product specialist for 6 of those years, supporting Allen Bradley components. I've been with Rumsey a little bit less than 2 years, and I cover the Lehigh Valley, northern Montgomery, Bucks County, and northwest New Jersey. So here's just an overview of the Allen Bradley overload relay portfolio. So the E300 came out several years ago. Some of you might be familiar with that. That's the relay we'll be discussing today. A lot of features. That's a networked relay. But recently, Allen Bradley has released the E200 and the E100. So the E200 came out last year. The E100 was just released recently. The E100 will be replacing the E1 Plus, and we'll be doing that transition this year. The E1 Plus is a very common relay. A lot of people are using them, so that will be a big transition for us. And the E100, the E200 are non-networked units. Here is an overview of the SMC portfolio soft starters. So the SMC3, the SMC Flex, those have both been around for a while, good soft starts. The SMC50, which that's the unit we'll be discussing, that came out several years ago, and when they first released that was just a solid state power structure. Recently, last year, or maybe the year before that, they released the integrated unit. So that has a contactor that sits inside of that. So after it ramps up, automatically switches over to the contactor, where the solid state unit After ramp up, it just continues to run on the SCRs. So why Rockwell Automation Smart Motor Control? So the products we'll be looking at, the E300, the SMC50, be mentioning the drives, and also the power monitors. So you've heard a lot about Studio 5000 already, industry-leading programming environment. All of the smart devices get integrated into that, so you've got one platform to work from. You've already heard about add-on profiles. All of these smart devices have an add-on profile that you can download, and this is really what sets us apart from others, that a part of the engineering is already done for you to simplify on installation. Some of the features that come: automatic device configuration. For these products, thermal capacity utilization, which percent TCU. You get advanced protection for your motor, data and diagnostics that come with it, DEVICELOGIX, and energy monitoring. So here's a few that we're going to look at, but it's not an exhaustive list. So automatic device configuration, it's similar to the sensors and what Donna had said. So the E300, SMC50, and the drives have this. It's pretty common in drives. A lot of people are doing it already. But the parameters configuration sit in Studio. One of these devices fails. Third shift mechanic just needs to get this line up and running, takes the old one out, wires it up. The PLC recognizes that there's a new unit in there, automatically downloads the parameters. If there's a firmware update that has to be done, it will do that. No software or programming required for the person doing the installation. It does its thing and fires back up, and the line is rocking and rolling again. So this could be a big time saver and cut down on your downtime. So thermal capacity utilization, or percent TCU, how we refer to it. So this is in the E300 and the SMC50. This is a neat feature. So when we think about overload condition, a lot of times we think about amperage. So the motor has an FLA of 3 amps, 4 amps, and when we put the overloads in, we set it at whatever the FLA is, and we think, okay, once it goes over that, it's going to trip, and we need to deal with that issue. But inside of these electronic overloads, it's actually doing a calculation, and it's looking at your amperage over time compared to the FLA, and it tries to figure out the stator winding temperature, because it's the heat that's actually going to deteriorate the motor, not necessarily the amperage. So it does that calculation in the overload, and when you put this on a network, you can get this information and then make it available to an operator or a maintenance personnel. So now we can predict when that motor or that overload is actually going to trip and shut down the line. So under normal operating conditions, it may be hovering 20%, 30%, something like that. But once that starts climbing 60%, 70%, 80%, we can see, okay, we've got an issue coming. Let's try to take a look at it and deal with that before we have a shutdown. So we can look and say, we're at 95, 96, I'm not going to shut down yet. We know as soon as we hit 100%, that overload's going to trip, and then we're going to have an issue. So that can be a neat feature and helpful in trying to avoid some problems. So here is a HMI faceplate. This is for the E300. This one is already engineered and designed by Rockwell engineers. This is available for download. And this gives a good overview of all the features, at least most of the features, that the E300 can give you. So top left corner, you can just see that green relay status. Green is good, red means I've tripped some sort of an issue. You got your digital inputs and outputs underneath that if you're using any I/O with the E300. You can monitor your last trip date at the bottom left there. In the middle, you've got your motor status, so line voltage, motor current, motor voltage, all that is good. You can monitor ground fault. Are we in a tripped condition? Are we getting close where we have a warning light coming on? Right next to that, you have your motor parameters. So what is the motor current at? 18 amps in this case. There you also see your thermal capacity. So there's a percentage, 23%, we're good. Underneath that, you have estimated time to trip. So it looks at that calculation. It looks how quickly that percentage is rising, and it can give you an estimated time to trip, which can be very helpful. And then underneath that, you can also trend out the motor FLA or percent TCU. And then you can also see some tabs up top. You can have some alarms that you can look at. You can look at power and energy, which the E300 can also monitor, and then also any RTDs that you have wired into the motor as well. So this is a nice HMI faceplate that can give you a lot of information and help you make a lot of wise decisions, keeping that line up. Okay, so here is DEVICELOGIX. So DEVICELOGIX is like a mini PLC that gets embedded in these components. So the E300, SMC50, PowerFlex drives have this feature. And this can be very helpful. You see some screenshots there of the programming, what it looks like. Let's say you have some remote motors or remote pumping stations, and you put one of these devices in there, and you don't want to get into programming or editing the main PLC program. And it's just a simple run. Let's say you got 3 motors that you want to stagger how you start them up. Well, you can do that in DEVICELOGIX. You first start the first one. It does its ramp up 20 seconds, and then you can start the next one. After that ramp up is done, then you start the third, and et cetera, et cetera. Or another application that could be helpful, let's say you are running these on the network and the network goes down. Well, you can have DEVICELOGIX kick in, and you could either do a controlled shutdown, or you can have it automatically switch to manual control. And DEVICELOGIX can help you do that to keep it going. And here is energy monitoring. So the E300, SMC50, and drives can all monitor individual motors, and they can do some energy calculations, your power usage. The power monitor, which we haven't mentioned yet, the power monitor can actually look at an entire line. You can put that on your incoming 3-phase, and it gets all these, all this data that you have now. A fun fact, 65% of industrial electricity is consumed by motors, and that's a big number. So without actually monitoring your energy, you're not sure where all that energy is going, where your costs are going, your peak demands. All of those things can be calculated, and then you can make some informed decisions on how to start things up, when to start them up, or maybe where you're having issues, why you're using more than what you were last month. And you can have this data historical. You can get it out of the device, get it into factory talk, display it, analyze it, and make some decisions. And you see there on the bottom left what some of those displays might look like, having it displayed on a tablet there. And it can just be helpful information. If you're not monitoring, then you don't know where your wasted energy is going. And here is power quality feature. So the Power Monitor 5000, there's a couple different Power Monitor units, but the 5000 has the ability to look at power quality. And power quality often gets overlooked, at least from my experience, but it can create a headache. And I just had an application not too long ago where a customer was having an issue. This one device kept tripping and faulting out. And we were looking at everything, could not figure it out until we put a high-powered meter on it and was able to look at the sine wave, and sure enough, they had a power quality issue. So when we talk about power quality, what do we mean? We're looking at sags, short interruptions, any harmonics or surges, or under and over voltage. And what causes bad power quality? Could be external to the panel, or it could be internal. And in our case, we think it was something internal, actually, that was causing the issue. So with a lot of smart devices and the way technology progresses, more and more electronic components are getting installed and put in these panels, and they are sensitive to bad power quality, and they have to have good incoming voltage to that. So the Power Monitor 5000 allows you to set up alarms for bad power, and it's something that you can monitor, and if you're having issues, this could be a big factor in that. And here's some links on the Smart Motor Control blog, a brochure, and then some product pages here, which will all be sent out with the presentation.
All right, thank you, Joe. The one thing that I'd like to point out, just because it does get overlooked, or and I don't know if overlook's the right thing to say, but is not always shown or known about, was the safety functions website that Will had pointed out in the middle. He showed just the one document that shows, how to use, that specific safety stuff in a system. However, if you go to that safety function website, and we'll make sure that we have links to it when we send out our follow-up to this call, there's a lot of information on there, from using SIP safety to, drive safe off, the advanced safety functions that are in drives and servos now. And all of that stuff is up there, and many of those PDFs, which I never knew, they actually have multiple links on the left side, or multiple tabs on the left side. They'll even have the sample ACD files and ACAD drawings in those, embedded within the PDF itself. So I do want to stress that that's an important site to look at, and it can help you engineer through a lot of safety functions. So with that, I want to thank everybody for tuning in today. If you have questions, feel free to talk to any Rumsey representative or any of the specific specialists that we're presenting here today. We will have and continue these calls every Tuesday and Thursday through the end of May. And thank you, everyone.